All right, guys. So in this video, we're going to get some practice drawing our first Lewis structures of covalent compounds. But before we get there, just recall about the noble gas configuration, right? Before we were saying you need to gain or lose electrons to have the same number as the nearest noble gas. This is true. Now we've kind of expanded upon that a little bit, and we're saying, they have to have the same electronic configuration as a noble gas. Okay. So just saying about the electronic configuration. That's going to be, for most cases, 8 valence electrons, okay? Except for helium, that has 2 valence electrons, right? So hydrogen, which is going to become like helium, is going to actually only form 2 valence electrons. By the way, a neon sign, right, is exactly like the hydrogen line spectrum experiment of quantum chemistry we talked about 2 chapters ago. And I would have done this demo in class, but you can basically take different gases or make any element a gas, do this, apply electricity through it, and they'll glow different colors, characteristic of the different electrons being excited to different orbitals. Some beautiful, interesting types of colors you can make. You can also have mixtures of gases and get different colors, colored signs, so to speak. Okay. So this noble gas thing, right? Most of them have 8 valence electrons, except for helium. So we are going to want 8 valence electrons. That's called the octet rule, okay? Or duet rule for hydrogen, where you want 2 valence electrons to be like helium. There are some exceptions to these octet rules, which we will learn about in a few slides later on at the end of this chapter. And so I want you to think about these as octet guidelines. It's not 100% true, but most of the time this will be true, and I'll walk you through later on where the exceptions are. So we're going to build some molecules. We're going to write these Lewis structures. This will eventually help us visualize in 3-dimensional space what these molecules look like, okay? And generally, we're going to obey the octet rule and the duet rule for hydrogen or helium, but helium doesn't form any compounds, so it's just going to be helium with 2 electrons around it. And so what this is going to look like is, when you have 2 chlorines, we talked about this example, they're going to form 1 covalent bond and share 2 electrons, 2 electrons per bond. We call those 2 electrons a bonding pair of electrons. And most people don't actually end up writing them as 2 electrons there. They draw them as a line. So we call that a single bond. The single bond has 2 electrons in it. The ones that aren't in the bond, these ones in blue, those are called lone pairs. They're by themselves. They're not called a bond. And so they're called lone pairs. Okay, so just some nomenclature. So this is what we're going to do. We're going to count the total number of valence electrons to draw these structures. These are covalent compounds now, not ionic compounds, because those you just form the ions and then you make ionic bonds. This is for covalent. We're going to have sharing of electrons. We're going to write a skeletal structure without any bonds. We're going to have a central atom, and we're going to arrange the atoms around the central atom. The least electronegative atom is going to be our center atom, at least most of the time. And hydrogen is always not going to be at the center. Why? It can only form 1 bond because it follows a duet rule. So it can never be at the center. Things at the center are going to form, more than 1 bond a lot of times, if they're at the center by definition. Okay. Then we're going to use a pair of electrons, i.e. we're going to draw a line to form bonds between the atoms. And then we're going to use the remaining electrons to complete the octet rule for the outer atoms and duet rule for hydrogen. And then we're going to complete octet rule for the inner atoms at the end. Okay. And if we run out of electrons to satisfy this octet rule, we're going to have to make a double or triple bond. So a lot of steps, you just have to practice it and it'll get easy and you'll kind of see it. And so let's in the next video go over those actual examples because now we introduced it.